Hello, welcome to the Chapter 1.3 video lesson series. I'm going to go over Chapter 1.3 in a couple of videos that are all 15 minutes or less. And this section is all about experiments and observational studies. This is one of my favorite sections. Instead of answering multiple choice questions on this, I'm actually going to have you fill out a discussion form with a bunch of question prompts. And then hopefully we can do an online dialogue with some of your classmates. But let's start going through the material. First things first, here's the outline. We're going to talk about association versus causation, confounding variables, observational studies versus experiments, and randomized experiments. All right, let's do a quick review question. To estimate the proportion of students who support a smoke-free campus, you compute the proportion that say yes after responding to an email sent to all students asking, do you support a smoke-free campus? The data collected is, at these options, but not biased. Biased because of wording. Biased because asked over email instead of in person. Biased because responses may be inaccurate. Biased because volunteer samples are almost always biased. All right, what do you think? All right, and maybe the best answer, maybe not the only answer here, would be is definitely biased because volunteer samples are almost always biased. If you thought there could also be an issue with the wording, it might not be completely wrong. Wording is kind of a tricky issue, but there's definitely an issue with that volunteer idea. It's not necessarily completely bad to get volunteer data, but we're always going to assume there's some type of bias when you do that. Okay, so on to new material. We're going to say two variables are associated if values of one variable tend to be related to values of the other variable. So association, the more technical mathematical term would be correlation, which we're going to come back to later in chapter 3. But I like this idea of association, just means there's two variables tend to be related. And two variables are causally associated if changing the value of changing the value of the explanatory variable influences the value of the response variable. So these could be very different, actually, and causal associations in general are a heck of a lot more difficult to figure out than just figuring out when two variables are associated. So we'll look at many examples on these lectures. Okay, so just I have a couple little quick questions here on wording. So we're not saying whether the statements are correct or not, just the wording. Does the wording imply association that's not necessarily causal or causal association? Daily exercise improves mental performance. And hopefully you are thinking causal association, that idea of improving. This is saying that if you exercise, more, do good exercise, and that will increase your performance. So that is a causal association. How about this example? Want to lose weight? Eat more fiber. And that wording is also causal. There's an implication in the wording that eating fiber will cause you to lose weight. Cat owners tend to be more educated than dog owners. This is an example of an association, but there's no claim that owning a cat will change your education level. In fact, it might be the opposite. Maybe people that are more educated tend to buy more cats instead of dogs, but there's no causal association implied in that wording. Piracy and cell phone usage have both increased greatly the last 10 years. As another example of an association that's not necessarily causal. There's no claim that piracy causes cell phone usage increase or vice versa. So it's just an association. All right, here's a quote from the New York Times in 2012. Education seems to be an elixir that can bring us a healthy body and mind throughout adulthood and even a longer life. This is Margie Lockman, a psychologist at Brandeis University who specializes in aging. For those in midlife and beyond, a college degree appears to slow the brain's aging process by up to a decade, adding a twist to the cost-benefit analysis of higher education for young students as well as those thinking about returning to school. So from this, and this is there's a study done on a population group looking at their brains, and from this information, people with college educations did have a slowed the aging process. Does this convince you that college degree slows the brain's aging? As a college professor, my career is teaching college. I want this answer to be a yes, but from this information, we can't say yes. So the answer might be yes overall, but it could be possible that people who go to college may be different to begin with, that it's not the actual college experience that slows the aging process. It's the people that choose to, give up 2 to 6 or 8 years of their life to study might be different to begin with. And that's what we talk about. There's definitely an association between college degree and the brain's aging process, but that causal relationship is a lot more difficult to confirm. All right, sorry, I got to fix this graph up, but this is from another study, and I think it was in 2012, looking at life expectancy. On the y-axis, we have life expectancy of various countries. So right here, we've got Japan, France, United Kingdom, United States, all have fairly high life expectancy, getting close to the 80s. And then we have some other countries that have a lower life expectancy. And then we're looking at TVs per 1,000 people here on the x-axis. And we'll get to chapter 2, we're going to talk about this R. So if that means nothing to you right now, ignore it. We'll come back to this correlation value R in chapter 2. But hopefully you see there's definitely a trend here. The more TVs per capita, the higher the life expectancy. So should you start buying more TVs to live longer, or maybe start a charity to bring more TVs to Angola or Uganda or South Africa? Probably not. That doesn't make any sense. TVs are not going to cause anyone to live longer, I think is a reasonable statement to make. But here's an example of there's an association, definitely a strong association between life expectancy and TVs per capita, but I don't think anyone reasonable would claim there's a causation here. So that leads me to talk about confounding variables. If you're looking at two variables, such as life expectancy and TVs per capita, there could be a third variable or more, third or fourth or fifth, but definitely a third variable that is associated with both the explanatory variable and the response variable, and we call that a confounding variable. The third variable that maybe we don't think about that wouldn't be initially thought about when doing a study. And a confounding variable can offer a plausible explanation for an association between the explanatory and the response variables. So whenever confounding variables are present or may be present, sometimes it's kind of obvious to figure out what they are, and sometimes it's not. A causal association cannot be determined. The idea of doing experimental studies, which I'm going to talk about later in this video series, is a way at trying to figure out connections between two variables by getting rid of confounding variables, or at least treating for them. So we kind of visualize. We've got explanatory variable and response variable. The idea is just changing the explanatory variable, then change the response variable. But what if there's a middleman, a confounding variable between these two? And then it gets a little bit trickier. Does the explanatory variable directly change the response variable, or is there some confounding variable that actually might be more important in terms of changing the response variable? So let's go back to that last example about TVs and life expectancy. Number of TVs per capita. Oh, went too fast. That's okay. I think hopefully we're thinking about this. What's the confounding variable between these two? I think the most obvious answer, and this is not the only one, is wealth. If there's more TVs per capita, well, that probably has something to do with the wealth of the nation. If a nation is wealthier, they're going to have more TVs per capita. And then how would that change their life expectancy? You generally think the more wealth a country has, the better their health and medical system is going to be. You can talk about nutrition, infant mortality, et cetera, et cetera. There's probably a lot of other confounding variables, but I think the main one would be wealth. All right, okay. So this study came out a couple years ago. I think I was teaching stats when this came out about processed meat consumption and cancer rates. There's a cool, put a link down here looking at cancer rates. People eat hot dogs, hamburgers, bacon, different processed meats. And there's definitely, going on here, a strong correlation between eating people who eat a high amount of processed meat and having higher cancer rates. I love my hot dogs, but that was a little disconcerting, or at least made me think about my diet a little bit more. So I want to think about, could there be any confounding variables here? There might be two sides of this. People who really love their processed meat want to say that, no, it might be something else. Maybe people who eat processed meat tend to exercise less or drink more alcohol or not sleep as well. There could be many other ways, any other health variables that could lead to higher cancer rates. So in order to make a direct causal relationship between people who eat processed meat and cancer rates, you'd have to kind of treat for those variables. Say like, oh no, it's not actually that people who eat meat exercise less. It is the meat consumption that's leading to the cancer rates. And right now, this is still up for debate. I think if you kind of read through some studies of the last couple of years, the evidence is getting stronger that people or cultures or people groups that eat more processed meat tend to have higher cancer rates, even counting for exercise and lifestyle and socioeconomic status and whatnot. But it's not completely done. And I would argue it's never going to be completely done because humans are complicated creatures. But at some point, the evidence does get too strong. I think a similar debate happened in the 1950s, 40s, 50s, 60s about cigarettes. I think took a long time for the FDA, the federal government, health agencies to, I don't want to say prove, but build a strong enough case that no, the cigarette smoke itself is what leads to the cancer rates, not any other confounding variable. And even that is still probabilistic. There are people that could smoke a pack of cigarettes a day and never get cancer, but probabilistically, if you do smoke a pack of cigarettes a day, the evidence says you have a much, much, much higher rate of getting lots of different types of cancers. And that kind of process is happening right now with, looking at processed meat. All right, so this is another one of my favorite studies. I put a link down here, so if you open up the slides, if you want to read more about this, about coffee consumption and lung cancer. So there's a link between coffee consumption and lung cancer, and there's some studies done in the 80s and even more recently, I believe in Asia. This article talks about some studies done in Asia about coffee consumption and lung cancer, and that terrifies me because I love my coffee. I don't want lung cancer. And one interesting thing, what could be a possible confounding variable? Something that might be connecting coffee, people who consume a lot of coffee, and lung cancer. And this might be going away because more people are drinking coffee. But one confounding variable could be cigarette smoke. People who smoke cigarettes, or I should say people who smoke coffee, do tend in some cultures, some areas, to also smoke cigarettes. You kind of imagine, especially in the 80s and 70s, you had your coffee break along with your cigarette break. And so it might not be the coffee at all. There's some studies that treat for that, say coffee consumption actually could lower cancer rates, but there's still correlation between these two, and it might have nothing to do with coffee. It might be smoking cigarettes or something else entirely.